All right, we are live. Leave. So welcome everybody. Um, Today is day 4 of Caribbean Developer Week 2018. I believe this is the 6th session, and I am Ariel Wolffe, and I will be hosting today. This morning we had a really awesome session with Louis Kinley. And today, this evening, I should say, we have Anil Ramnanan, and he is going to do a super awesome session as well, which I'm also really excited for. This session is a developer's introduction to machine learning and computer vision. Hey, Anil, how are you?
Hi, I'm good. Glad to be here.
Nice, awesome. So let me just give the viewers a little background into you. So you are a graduate of the University of the West Indies with an MPhil in computer science.
Yes.
You have experience as a full stack developer, both with web and mobile applications for UE Open Campus. And you are currently doing research in the area of computer vision. That's pretty exciting with TT Lab and UE St. Augustine.
Yeah.
Yeah, that sounds pretty awesome.
Yeah. So,
Um, Go ahead.
yeah, no, I'll go into some of what we're doing in the presentation.
Okay, awesome. All right. So, like I said, today's session is a developer's introduction to machine learning and computer vision, and you'll get a more oriented approach, to machine learning and computer vision, and show how developers can easily get started integrating these concepts into their application. So, without taking up too much time, I'll hand over to you, Anil.
Hi. Thank you for having me and giving me the opportunity to do this presentation. Um,
Awesome.
so, uh, I'm a developer with the University of the West Indies. I'm actually a systems administrator at Open Campus, and I do some development for my research with TT Lab, where I'm doing my PhD in the area of computer vision. Um, so we hear a lot about AI and machine learning and a lot of those terms these days, and it's actually a area that's blowing up. There's a lot. If you look at all the big companies, a lot of their focus now is in the area of artificial intelligence and machine learning and deep learning and those things. And so, as developers, I mean, these are very powerful tools, but it could be a little daunting to get into when people look at it because um, a lot of people look at it within the context of research or as a data scientist. When they start to look at things like AI and machine learning, getting familiar with the concepts and that type of thing, there's a lot of mathematics involved and stuff like that. People get kind of sometimes turned off with it, but it's actually not as bad as people think it is. And you actually have a lot of powerful tools you could use uh, in terms of machine learning and artificial intelligence. So, sorry, I have the cold. So if I cough a little bit, bear with me. So one of the things we want to look at is some of the common terms being used. So you hear a lot of terms, artificial intelligence, machine learning, deep learning, these types of things. And a lot of it, especially when it comes from big companies, they use it as buzzwords. They use things interchangeably. So actually trying to get a handle of what these terms mean um, sometimes could be a little difficult because a lot of people use terms interchangeably. Um, but when you so I just want to kind of clarify some of the terms so that in the context of what we'll be presenting, you'll understand where we're going with terms like artificial intelligence and machine learning and that type of thing. So we can start with artificial intelligence. And artificial intelligence has been around a long time. And a lot of people, when they hear artificial intelligence, first thing come to mind, Terminator and Skynet and that type of thing. But really, all artificial intelligence means is that we want machines to do things that require the intelligence that humans have. So if a human being could do something, we want them to be able to develop a machine to do something. And it doesn't have to be everything that a human being does. But if you look at a specific task, you want a machine to do a specific task the way a human would. Look at self-driving cars. You want there's a good example of artificial intelligence in that you want that machine to drive the way a human would drive. Well, not all humans, but responsibly. So that's basically what artificial intelligence is, and it's been around. It's been part of our lives, and sorry, in different areas for a long time. So look at machine learning. So what is machine learning? Well, for artificial intelligence to work, you have to teach these machines to do tasks, or to deal with situations the way a human would. So you have to kind of teach it, and you want to teach it using data and identifying patterns so that it could make the kinds of decisions that a human would make. And you want to be able to teach it with little or no human intervention. So the idea of machine learning is that you can create a model for a task, teach it to do a particular thing, and it can gather data and keep learning as it goes along. So machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. And deep learning is basically where you teach the computers to learn by example. So you create a model and you train that model with sets of data, and then we use neural network architectures similar to the brain to basically train those neural networks using the labeled data so that it learns and can then be able to perform particular tasks. So in the area of that I'm looking at computer vision. Now, computer vision is basically trying to teach a machine how to get data from an image or video the same way a human does. Now, when you look at when a human looks at something, you would look at a person and you have a picture of that person, but in addition to that, you can tell that person's height. You can tell whether there's a male or female. You can tell what they're wearing, what color clothes they have, where they are, that type of thing. You can get contextual information from that image. So computer vision is basically trying to teach a machine to be able to gather that type of contextual information from an image so that it can make decisions the same way a human can based on that information. And you'll hear a lot about convolutional neural networks. Basically, these are specific types of neural networks. And these are commonly used with visual imagery. So in terms of image processing and computer vision, convolutional neural networks are the neural networks that we usually use for that type of application. Okay, so where do we use computer vision? Well, we actually use it a lot, and these days, pretty much everybody uses it, whether you know it or not. If you look at social media, when you upload a photo and Facebook asks you to tag this person, labeling for images, that's computer vision because it recognizes faces, it can recognize places and surroundings, and that type of thing from images. Look at like self-driving cars, where they rely on things like object detection, object recognition, medical applications. So you have applications that could say, look at CT scans and try to determine what's wrong with a person based on identifying anomalies in those scans. Sorting applications, so like factories where you have automated sorting systems where you could use computer vision to kind of look at products, for example, like fruit, and sort them into different sizes or colors and that type of thing. And then there's security applications, which is a big one, facial recognition, things like left object recognition. There are systems that can look at, say, a camera feed at the airport and detect if somebody is walking with an object, if the person leaves that object and walks away for a particular amount of time, and flag that type of behavior. So as developers, I mean, that type of functionality is something that can be very useful. And when you want to implement that type of thing in your applications, until recently, I mean, it was difficult to do. As a developer, you don't want to get into uh, these types of applications where you can you can start adding this functionality without having to know a lot about the underlying architecture of the machine learning and artificial intelligence systems. So a lot of companies have come up with APIs, and APIs based on their own, AI and machine learning algorithms and software on the back end. So the easiest way to jump into it is actually by looking at these APIs, because you get a feel of what machine learning and computer vision can do without having to do a lot initially to understand it. Although I do encourage people, once you get into it, to really get into it and understand what's going on under the hood. As any good developer, you want to understand what you're working with and how it works. So for Google, they have their Google Vision API. They have it for both web and mobile. Microsoft has Microsoft Cloud Vision. Amazon has something called Recognition, and IBM has Watson Visual Recognition. So a lot of the major players in cloud computing have some form of APIs for computer vision available. And there are startups coming out every day with some form of computer vision or machine learning backend. So there are more and more coming out every day. So what would the cloud API provide you? Well, APIs provide you, they provide high level APIs for things like label detection to kind of give you information about what is in the image. A lot of them do explicit content detection. So, for example, if you run in a service that relies on scanning uploaded images to ensure that you don't have explicit content, they provide APIs for that. Logo detection, things like landmark and celebrity detection. optical character optical character recognition. Um, so for things like if you want to scan documents and get text out of those documents, they provide that, and things like face detection, facial recognition. So these APIs are available from most of these cloud providers in one form or another. Some more heavily into certain areas than others. So like facial recognition, that kind of thing. You'll find like Amazon has a lot of that in their recognition software. So that is actually one of the easier ways to get into. If you want any of these types of features, there are APIs for that. So let's look at a cloud API demo. So if we look at a simple application, and this is like a quick and dirty PHP application I knocked up using Google's Vision API. And the idea is to just basically post an image and get the labels for that image. So, and you'll see it's very little code here. You basically, use the API client, initiated, and you get a URL, and then you pass that URL to the API, and the API will get the labels and print it out for you. So it's actually very, very simple to get into. So if we used a particular image, and paste that URL in. Basically, what it's supposed to do is contact the API, pass it the image. So you'll see the image that it passed was a crowd, and return the labels associated with that image. So it will tell you the labels associated with that image: a crowd, a social group, audience, community, etc. So basically, if you want to tell something about a particular image, they have already done all the work of classifying labels for those images. So all you have to do is pass it the image and get the results. So these cloud services do a lot of work on the back end for you. You don't actually have to do anything much. The only constraint is you are reliant on their models and their data sets. So if you wanted to do something that doesn't conform with the standard set of features that is available, then you will have to start looking at developing your own models for computer vision or your own machine learning models. So how would you do that? So there are a lot of libraries that let you get into developing these models. Most of the large organizations like Google and Microsoft, they have toolkits available. The most popular ones are TensorFlow, which is Google's toolkit, and that is what they use on the back end for all of their machine learning and AI services. There's Cafe, Microsoft Cognitive Toolkit, Theano. So these libraries allow you to develop your own models, train your own models, so that if you have a specific application you're looking for, you can get into that. But there are also frameworks that are built on top of those that expose the features of these models without you having to get into it. Kind of like how you use frameworks for JavaScript something like that. There are frameworks for these or libraries that are built on top of these. So you have something like TF-Learn, which is built on top of TensorFlow, or Keras, which is like a high-level API, and that actually will fit on top of multiple libraries. So if you're using TensorFlow or CNTK, you could develop your stuff in Keras and port it from one to another without having to change your code. There's things like Cafe 2, which will, sits on top. It's more lightweight and modular and sits on top of Cafe. A lot of these, they do the higher level stuff for you. But again, if you want to get into the nitty gritty, you'll have to go, like directly into TensorFlow and that type of thing. So there are different levels you could look at. So what I want to show you is if you want to build your own model, we could build, for example, an image classification model. So what we're going to do is look at an image classification model based on a data set that we specify. So we're going to, create a data set and use that data set to train a model. We're going to use a convolutional neural network. So you're going to build a classifier that will say we have an image of this type, and when you send that model an image, it will determine whether or not that matches the type of image you specified. So in order to do this, we need to create an image set. So we'll do a image set for training, and the bigger the image set, the better. But this is basically a set of images that identify the particular, type of object or, scene or whatever it is you want to classify. So you'll have an image set to train the model with, and then you'll have an image set to test the model with. So that testing image set is basically an image set that you have specified that these will or should produce positive results. So that way you'll know whether or not your model, is learning to identify the right image. Because when you pass it something from the testing, it should recognize that. So what we're going to use is we're going to use Keras and TensorFlow. The Keras, like I said, sits on top of TensorFlow. It's like high-level APIs. So it's actually very easy to build a classification model. It's not a lot of code at all. So what we'll do is I'll show you the structure of how I set out the application, and we'll do some tests with the application so I can show you what the results would be when you try to classify an image. So this test application is what I call doubles or not doubles. I don't know if anybody looked at, there's a show called Silicon Valley where this guy developed an app that's telling you something is a hot dog or not a hot dog and get like millions of dollars for it. But this is basically similar, but the idea is to kind of show you how you can train a neural network to identify a particular type of image. So how this works is we have, so this is the structure of the application. Now I use a tutorial from a blog called PyImageSearch, and they provide tutorials for developing all sorts of machine learning applications, stuff with Keras, TensorFlow, CV. So what I'll do is I'll do like a list of resources and I'll send it out. So the first thing you have to do is set up your um, image set or your data set. So in this data set, we basically have two sets of data. One is doubles, so pictures of doubles, all different types that we could look at. And the other are pictures of things that are not doubles. So uh, this kind of gives you an idea of the types of data sets we're looking at. So when this thing is trained, if I pass it a picture of something, it should determine based on what's learned from what is doubles and what not doubles to classify an image appropriately. So what we do is we train this model, and so when we train it, we actually end up with a doubles, not doubles model. And this model, once it's trained, we could take this and deploy it on a web server. We could deploy it on a mobile application, that type of thing. And the training is basically very simple. This is basically code I took from the tutorial, modified a little bit. And it basically gets the image set, sorts it, well, not sorts it, like kind of randomly shuffles it. And it creates two partitions for the data. So it splits it into a training and testing set. So 75% is used for training, 25% is used for testing, so that once it trains it, it uses so many images to train it, and uses the rest of the images to kind of test the model to make sure that it's on the right track. All right. So basically, initializing model, if you see, like, training the network is actually very simple. There's a few lines of code, and this part is just plotting out a graph of the accuracy of the training model. So once we have the model trained, and it trains and creates this model file, doubles, not doubles, we want to test it. So in order to test it, we basically just pass it an image, and if it works, then that image should let you know. The script should let you know if the model determines whether it was doubles or whether it wasn't doubles. So let's see. So these are some of the example images we have. So we have, images that are doubles, images that are not, obviously, and different types. Now, let's see if we could do this. Okay, so as you can see, it gives like a percentage of recognition. It says like 51.49% positive that this thing is doubles. If we were to run it for something else,
Hey, Anil, just to sort of interrupt you there, but I think they aren't seeing that well the code, so perhaps maybe you could zoom in when you're on your editor, displaying code.
Oh, okay. All right, no problem.
Okay.
Yeah, no problem. The code itself is actually I'll send out like the code and stuff after. so everybody will kind of get an idea of what it is. So yeah, so you'll see this one. This image is it's hard to see, but 68.84%. Um, if we look at something that isn't Big Four. Okay, so it is 100% sure this is not doubles. Um, so as you can see, um, this model, I mean, it gives a pretty good accuracy. There's still false positives because I only use like 191 images uh, to train it, 191 images of doubles to train it. So it doesn't really have a lot in the data set right now. The larger the data set, the obviously the more accurate it will start getting as to whether something is or isn't. So, but that is basically um, an example of like how you could create uh, your own image classification service. So I could take that, and as I said, I could put it on a mobile application or web application, whatever, and use that for whatever application I want. And so I think that's basically the idea of uh, computer vision and getting into things like machine learning and AI. As you can see, it's actually very simple. The code is not complex at all, and there are now a lot of libraries, a lot of frameworks there to kind of help you get into it, so you can, be as abstracted as you want out of it. So if you want to like know nothing about it, you could use the cloud APIs and just use the functionality, and you don't really have to care how it works. You could go down to things like Keras, where there are higher level APIs, but you still get the flexibility to train your own models and do what you want. Or you could go like directly into things like TensorFlow and that type of thing, and um, mess with the models and that type of thing from a lower level. So um, there's a really neat path to allow you to kind of get into it, and it's actually not as daunting as people think it is. So I don't know if anybody has any questions.
Hey, okay, awesome. We actually do have questions. Lasana asked, have you
Mm-hmm.
used OpenVC by chance?
OpenCV, yeah, I use OpenCV.
CV, sorry. Uh-huh.
Yeah, so OpenCV kind of there's some machine learning stuff in OpenCV, but I've used OpenCV to kind of determine do things like object recognition on images. Actually, OpenCV is part of a project I was working on for schools to kind of take images of students and kind of determine things like their height and that type of thing. So it's actually like a really nice, powerful library that you could use in Python, and you can get a lot of good stuff out of it.
Awesome, awesome. Someone asked how much doubles you're really eating.
Um, More than I should, probably.
Yeah, I think you all had us with the doubles thing. We all want to know what's good doubles, what's like 100% real doubles, and what's not doubles.
Well,
Um,
I mean, I guess I had to continue training it. So
yeah, because I saw some pictures going around on social media the other day that definitely didn't look like doubles. Okay, so we have another one. Does tensor or other libs require special chip instructions? Example, VTX on Intel, etc., etc.
um, not really. Some of them do. I don't think Tensor does, but Cause like I had an error here from I can't find it now. Um, you could basically look at different versions of TensorFlow um, because they optimize it for different platforms. So um, I hope that answers the question. Does it?
Awesome. I guess I'll wait until he responds if that answers his question. Um, yeah. So I think most of us. Let's see. Let's see. Somebody says Python. Woohoo!
Well, I mean, for a lot of these, I mean, Python is kind of the go-to language for some of these. But for the APIs, you could use Python, you could use PHP, you could use Go, you could use Java, there's Ruby. I mean, there's a lot of libraries out there that allow you to interface with some of these cloud stuff as well as some of these lower libraries.
Nice, nice. So, back to your introduction, when you were giving us just like a brief definition,
Mhm.
um, is it right in saying it's more like a pyramid where artificial is like the big guy, and then you have machine, and then deep learning is
Yeah.
falls under it, right?
Some of each one is like a subset of the other. Because
Right,
because machine learning is basically teaching things for artificial intelligence, and deep learning is a way of machine learning and that type of thing. So um, some of those are subsets of um, the other. Something like
right,
computer vision is like a specific area of machine learning where we deal with images and that type of thing. But there are other areas where you deal with like normal data, like financial data and that type of thing.
right. Okay, awesome. Some very very cool stuff. Um, so where do you see like what are some of the things that excite you about machine learning and AI and where things are going?
Well, there's a lot of um, interesting work being done in fields like medical. As I said before, like things like not just in computer vision, but generally in AI. Um, there, so like computer vision, there are applications where you could they look at certain images, scans, and that type of thing to be able to determine things like tumors and stuff like that. Um, and those things, once trained properly, can actually have a higher accuracy rate than humans looking at it, and faster for diagnosis too. So there's a lot of interesting stuff in the medical area that I could see machine learning, helping out a lot. I mean, there's also stuff that in different areas that you want to look at and kind of be careful of. So as machine learning gets more and more prevalent, you're going to have to eventually, well, not eventually, but I mean, we're seeing it now where you have to deal with like the ethical issues of how and when and why using some of this um, some of these concepts.
Right. I wonder how long it'll take us here to get that sort of medical advancement.
Well, well, I wouldn't say close, but that's some of the research that's being done. I mentioned TT Lab before, and TT Lab is
Mm-hmm.
a group started by Professor Patrick Hussein at the University of the West Indies. Well, it's like a private um, kind of think tank where basically students and researchers work on um, research and apply them to practical problems. So you have a lot of partnerships with companies, and we have partnerships with things like the medical, UV medical, and that type of thing to kind of look at developing practical solutions by applying things like machine learning and AI to different problems. So what you find is like a lot of companies now looking towards a lot of these things like recommender systems and stuff like that. Um, those types of areas where they can use the um, the functionality of things like machine learning in their business model. So, but there are research projects. There's one that I'm working on. There's one that another person, Shelly Ann, is working on that does research into diabetes using machine learning. So there's stuff going on in the back that we're trying to kind of push to see how we can apply this technology.
Awesome, awesome. Sounds pretty exciting. What any advice would you give for developers really looking to branch into this area of development? Any advice?
Um, I would say start building stuff. There's enough out there that you could, kind of couple stuff together and build your own, um, applications and that type of thing. It's no longer like a high barrier to entry. As you saw with the API stuff, like few lines of code, right? And the
Right.
more you use it, the more you will see, areas where it would be useful. But I mean, my suggestion is, get into it, start trying stuff out and that type of thing. I mean, something as useless as doubles, not doubles is, I mean, useless, but still useful in terms of learning the concept.
Right. I can see trainees using this though. I really, really can. Um, so Lasana
Actually, you can't identify a doubles as so.
asks, true, but just to like prove which doubles is more looks better, I guess. I don't know. Lasana asks, do you know anyone publishing pages or papers or blogs in the region?
Yeah. If you go to lab.tt, you'll see a list of publications there. Um, you will, and there are a few papers being published right now.
Oh, nice. Really, really good. Um, so let's see. I'll just like give a 3 second interval to see if there are any more questions. Just give anyone the opportunity because we're a bit early, so we have time for a lot of questions. So Lisana also just gave some input. He said this would be useful if you have gigabytes of image files and you're struggling to classify them.
Yeah.
And
Yeah.
you don't want to upload everything to Google Photos and
Yeah. Actually, it is I've seen people like kind of do some models to kind of just sort their photos because you could get like you could amass a huge number of photos and
yeah.
manually doing these things could be hard. But you can build your own stuff to classify photos.
Yeah, I think that actually be useful for me. I have too many photos that are not arranged.
Yeah.
Cool.
Okay.
So thank you so much. This was really fun.
Sure.
I
No
hope
problem.
you had as much fun as we did. And again, thanks for taking the time to do this and to share all the cool stuff you're working on with us. We're looking forward to those additional resources.
Okay.
And um, to everyone watching, I hope you guys tune in tomorrow. We have some more talks, which again are going to be really exciting. It's good to hear from everyone around the region. Um, and so, yep, Anil, we hope you keep us updated. And
No problem.
have a good evening, everyone, wherever you are. And enjoy, guys. Thanks for tuning in.
Okay.
All right, thanks, Anil.
Bye.